All right, now we're to the bonus lessons. These are a little taste of what you're going to see in 8th grade. And this first one is about solving equations with variables on both sides of the equation. So we're used to just saying x on one side, the left, maybe the right, and then we kind of do some different things to get it by itself. But this time we're going to see variables on both sides. So here is our strategy. With these equations, you're going to see variables on both sides. So our first step now is going to be to collect all the variables on one side. Doesn't matter which side we take them to, but we want to get them all on the same side. Because our goal is to try to get x all by itself, but to do that we have to get all the x's together first. Once we do that, then we're just going to go ahead and solve it like normal. It's going to look a lot like a 1 or 2 step equation after that. One strategy is to move the variables to the side with the larger number of x's. So in this case I've got 7 on one side, 2 on the other. So a good strategy is to move them all over to the left side since I already have so many of them here. But here's what that's going to look like. We still draw our line down through the equal sign, but we want to get rid of these 2 x's. Well, think about what we would do if we wanted to get rid of this 5. They were adding it, so we would subtract it away. That's what we want to do here. We want to get rid of the x's over here, so we're going to, in this case, subtract them away. But we have to do that on both sides. Notice how I wrote the x's underneath of the x terms, because those are the terms that are going to get combined together. I had 2, I subtracted them away, so they disappeared, but I'm just left with 35. Over here, 7x minus 2x is 5x plus the 5. Now you see it's just a simple 2-step equation, and I just solve it like I normally did. Subtract 5 from both sides. So I get 5x is equal to 30. Divide both sides by 5. And even though I'm running out of space, I get x is equal to 6. So it's just one extra step there, moving all the x's to the same side, but then it still turns out to be the same type of problem. Yes, you still need to do your check when you're done. I'm skipping over it just to save time in the video, but you should always go back to double check. Plug in 6 for x on both sides, solve both sides, and see do they give you something that is equivalent on both sides. This next one we're going to take a look at the same equation, but we're going to do it twice. Our note up here is you can move the variables to either side. It won't affect your solution, and we're going to see that here. But a lot of people just are naturally inclined to having the variable over on the left-hand side, so they tend to always want to move it over there. But here's what it would look like if I wanted to move them all to the left-hand side. So here I've got negative 3x that I want to get rid of. I want to move it over here. So I've got a negative 3x. I want to get rid of it. So I want to subtract away my negative 3x. Well, I got to do the same thing over here. I want to subtract away that negative 3x. I want to get rid of it by subtracting it away. That part disappears, so I'm left with 8. Here, subtracting a negative is really the same thing as adding a positive. 12x plus 3x is 15x minus 7. Now I solve it like a 2-step equation. They're subtracting, so I'm going to add 7 to both sides. I get 15x is equal to 15, and then I divide both sides by 15 and get x is equal to 1. Now let's see that exact same 1 in reverse. Let's move the x's over here to the right hand side. To do that, since I'm going to leave the 7 alone, I want to make this into adding the opposite. And now I want to get rid of my 12x. Well, there's 12 of them there, so I want to subtract them away. But I got to subtract away my 12x over here. 12x minus 12x is 0, so I'm just left with negative 7. Here, I don't like subtracting when I've got a negative, so I make it into adding the opposite. Negative 3x plus negative 12x is negative 15x plus 8. Now it's just a simple 2-step. I subtract my 8 away from both sides. So I'm left with negative 15x. A negative and a minus don't work, so I'm going to make it into adding the opposite. Negative 7 plus negative 8 is negative 15. Divide both sides by negative 15, and I get 1 is equal to x. So notice it looks very similar down at the end, but instead of both of them being positive, in this case both of them end up being negative. Same final answer, one version tends to have more negatives in it than the other, but they both work just fine the same way. So I'm going to go through just a couple of them real quick. Again, put our 1 in front of our x. In this case, I'm going to move my x's to the right-hand side since there's more of them over there. I've got 1, so I want to subtract it away. That part disappears, so I'm left with 2. 3x minus 1x is 2x minus 1. Now it's a two-step problem, so I'm going to add 1 to both sides. 2x is equal to 3, and then I'm going to divide both sides by 2. In this case, you'll notice it didn't divide nicely. That's okay. You're going to start to get more and more complicated answers, and that's okay. In this case, I get x is equal to 3/2. So let's try it again. You'll notice this time there's only w's on this side. There's only a w term. There isn't anything else. That's a good sign that you might as well bring the rest of them over there since that's all that was there. So they were, since I want to get rid of my 4w, think of it as they were already subtracting 4w. So let me go ahead and add 4w to both sides. If you wanted to, you could have made it into adding the opposite, in which case you would have subtracted a negative 4w, which is the same thing as adding a positive 4w. So it all ends up working out the same. Here I get 7 left over, and over here I get 10w plus 4w is 14w. Divide by 14. Again, this one doesn't come out perfectly, and that's okay, but 7/14 is the same thing as 1/2. So again, I moved all the variables to one side and solved it like a two-step equation. All right, same thing here. I've got a negative 8y and a positive 4y. My suggestion is move it towards the side with a positive because the more positives you have in the problem, the easier life is going to be. So they've got a negative 8y that I want to get rid of. So I want to subtract my negative 8y away. Well, subtracting a negative is the same thing as adding a positive. So it becomes 12y minus 5 is equal to 7. They subtracted 5, so I want to add 5. 12y is equal to 12. And then it's just a matter of doing my division step, and y is equal to 1. So the only step we've added in is this very first one. We want to get rid of, we want to subtract away the y's or the variables off of one side, which allows them to only exist on one side of the equation, and then we can solve it like the rest of them. We leave that y over there, get rid of everything else to find out what our y is equal to.